Hello and welcome everyone. My name is Mona Yadav, and in this video we are going to learn about a numerical based on viscosity. So we are going to study a numerical based on viscosity. So there are various types of conditions in which we can study the numericals on viscosity. For example, the condition of parallel plates, fluid flowing through a pipe, lubrication. So in the case of lubrication, various oils are used or various substances are used which are having a certain value of viscosity. So we can have numerical based on the condition of lubrication, bearing, brake fluids, rotating shafts, etc. So these are various conditions in which we have to study about various types of numericals based on viscosity. So out of these many conditions, currently we are solving numerical based on the condition of parallel plates. So let's see the question. So the numerical on viscosity, problem number 1, it is if the velocity distribution over a plate is given by u equal to 2 by 3 y minus y square, in which u is the velocity in meter per second at a distance y meter above the plate, determine the shear stress at y equal to 0 and y equal to 0.15 meter. Take dynamic viscosity of fluid as 8.63 poise. So the question is given in such a way that if the velocity distribution over a plate is given by this equation. So let us take help of a diagram for understanding this. So here we know that this is a plane surface. This is the plane. Consider that this plane surface is having a fluid over it. So we are having a fluid here and the fluid is having a certain viscosity. Now through this diagram we can see that the velocity profile is in this way, which shows that, or we can have idea based on which, that the fluid particles near this bottom surface will be intact to this bottom surface and they will be having very less velocity, which can be neglected. As we can see here, it is near to 0, so that is negligible. So velocity here at the bottom surface of the fluid particles will be very less, but it will go on increasing as the vertical distance increases. So with the increase in vertical distance, the corresponding velocity of the fluid particles will also increase. So consider at this point, at this certain distance, the fluid particles will be having a velocity of u, whereas if we will go at a higher distance above this, the velocity of the fluid particles is u plus du. So du is the increased factor. So as because the distance, vertical distance is increased, so the velocity is going to increase. The particles will not be bound to flow at a velocity of u, but they can move at a higher velocity than u. That's why this du is the term increase in velocity which is added to the u. So this velocity profile shows us that at the bottom surface the velocity of the particles will be very less, but as soon as the vertical distance will increase, the velocity of the fluid particles will go on increasing. So this is the conclusion that we have to take from this diagram. Now near the plane surface, that means vertical distance is 0 at the bottom, but vertical distance is going on increasing as we are moving ahead. Okay, so let's consider that this particular point is the point where y is equals to 0. Okay, so in the question what is given, if the velocity distribution over a plate is given by equation u equal to 2 by 3 y minus y square. So basically the equation governing this velocity profile, we can consider it as it is u equal to 2 by 3 minus y square, in which u is the velocity in meter per second at a distance y meter above the plate. So determine the shear stress at y equal to 0. So what we have to do in this question, we have to calculate the value of shear stress, that is tau. So we have to determine the value of tau at y equal to 0 and y equal to 0.15. So consider that this particular point is a point where the distance y is equals to 0.15. So at these two locations, what we have to do, we have to calculate the value of tau. Tau, that is shear stress at y equal to 0, which we can say it as tau 0, and tau at a value of y equal to 0.15. So we can call it as tau 0.15. Okay. So let's start with the question. So what is given to us? First of all, a equation is given. U equal to 2 by 3 y minus y square. So after differentiating, therefore after differentiating this above equation with respect to y, what we get? We get du by dy equal to 2 by 3 minus 2y. So now we have got a equation du by dy equal to 2 by 3 minus 2y. Now for y, this particular value, we have two conditions at y equal to 0 and y equal to 0.15. So let us try by putting y equal to 0 and y equal to 0.15, so that we will get du by dy at y equal to 0 and du by dy at y equal to 0.15. So du by dy at y equal to 0, it is 2 by 3 minus 2 into 0, as y is equal to 0. So we get the value of it is 0.667. Now next, du by dy at y equal to 0.15. So by putting the value of y equal to 0.15, we get 2 by 3 minus 2 into 0.15, the value as 0.367. So this is the value of du by dy at y equal to 0 as 0.667, and du by dy at y equal to 0.15, its value is 0.367. Okay, so let's move ahead. Now moving ahead in the question, determine the shear stress at y equal to 0 and y equal to 0.15 meter. Okay. Take dynamic viscosity of fluid as 8.63 poise. So the dynamic viscosity mu is equal to 8.63 poise. So 8.63 by 10. When the value of dynamic viscosity is given in poise, then we have to divide it by 10 in order to get the value in SI unit form, that is in Newton second per meter square. So 8.63 divided by 10 gives us the value as 0.863 Newton second per meter square. So now we have the value of dynamic viscosity mu in SI unit form as 0.863 Newton second per meter square. As per the Newton's law of viscosity, shear stress, that is tau, is given by tau is equals to mu into du by dy. So now number one, see what we have to calculate is tau only. Determine the shear stress tau at y equal to 0 and at y equal to 0.15. So for calculation of this tau, we have the value of mu, we also have the value of du by dy. So now shear stress at y equal to 0, tau 0 equal to mu into du by dy at y equal to 0. So we have to take this value of du by dy at y equal to 0 only, which we have just calculated it as 0.667. So value of mu is 0.863. Value of du by dy at y equal to 0 is 0.667. So after multiplying these two terms, we get the value as 0.5756 Newton per meter square. Yes, secondly, same thing we have to do, but we have to do it at 0.15. Value of y as 0.15. So yes, this is the value of shear stress at y equal to 0, 0.5756 Newton per meter square. Second, shear stress at y equal to 0.15, that is tau 0.15 equal to mu into du by dy at y equal to 0. So mu multiplied by what? Du by dy value, and that value is at y equal to 0.15. So it is 0.863, that is the value of mu, that is dynamic viscosity, into 0.367. So 0.367 is the value of du by dy at y equal to 0.15. So this gives us the answer as 0.3167 Newton per meter square. So this is how we have got the value of shear stress at y equal to 0 and at y equal to 0.15. Thank you.